Paper 2, question 20, star question, so we need to make sure that all our workings are spot on for full marks. The diagram shows a ladder leaning against a vertical wall, so that's our vertical wall, and we have the ground, which means we can put it in this right angle. Even if we didn't have it in the picture, height and ground level are assumed always to be perpendicular, so we could put in a right angle there. The ladder stands on a horizontal ground. The length of the ladder is 6 meters, and the bottom of the ladder is 2.25 meters away from the wall. A ladder is safe to use when the angle marked Y is about 75 degrees. Is the ladder safe to use? You must show you're working. Well, you can't answer the question on whether or not it's safe to use until you figure out why. So that's basically what we need to do here. This is a right angle triangle. This is a right angle triangle, and you're asked to find an angle in it. It's a classic SOHCAHTOA trigonometry question. SOHCAHTOA being one way of remembering the three trig identities, sorry, not three trig identities, the three trig ratios that work in right angle triangles. The ones you're given at the front of your exam script, the sine rule, the cosine rule, they work for any triangle and technically will work in this. I mean, we could use a combination of those or whatever to figure it out. But in a right angle triangle, life's a bit simpler. We can use SOHCAHTOA. So before we do that, we need to identify which side is which. And the hypotenuse should always be obvious as the biggest side. Where your angle is, across from it is the side that's opposite it. And adjacent is the other one that is beside the letter. So in this question, we have a value for the hypotenuse. Doesn't matter if it's numbers or letters. You're just looking for what sides we care about and what sides we don't. We care about the hypotenuse because there's a number there. We care about adjacent because there's a number there. But we don't care about the opposite. So in other words, any of those equations involving O for opposite, we do not care about, which would be sine and tan. So cos is what we want. Our cos ratio is cos of the angle equals adjacent divided by hypotenuse. Adjacent here is 2.25, hypotenuse is 6, sub them in. And our angle x is actually called y in this question, so I'm going to just write that in. Cos of y. Same as before, you don't need this bracket around the angle or whatever your sine or cos or tan, but it's a force of habit of mine. Those doing A level, I would highly recommend you get into this habit of putting a wee bracket around it. Okay. Here, an equation you're trying to solve, you're trying to figure out what y is, you try and get y by itself. Y at this point in time is being caused, or has having cause applied to it, is having cause happen to it. So we need to undo that. The opposite of a cause is shift cause, or arc cause, or anti-cause, or whatever. Cause to the flying -1. Okay, it's not technically a power -1 by the way, but the inverse of cause is written as if it has a power of -1. Okay, if you I'll call it shift cause. If you shift cause a cause, because that's what you type in the calculator, they'll cancel each other out, leaving you with a y. And then if you shift cause, notice your bracket should open up, your calculator, should open up a bracket by default. If your calculator doesn't do that, you want to be in the habit of doing this, otherwise you might end up with a math error. So we are going to shift cause that fraction. You could have done that division and done it and got a decimal, but the reason why I just keep this as a fraction just now is if you have a decimal that doesn't have a happy ending, you know, is recurring forevermore, and there's a temptation to round your answer and then do shift sign to it. That'll make your final answer slightly less accurate. So I'm not going to bother doing the division, let alone rounding. I'm just going to shift sign all that and see what the calculator comes up with. In this case, it comes up with 67.98 degrees. Now, question asks, is the ladder safe to use? So you're asking yourself, is that value around 75 degrees? The answer in this case is no, it's not close enough for my liking. To me, being about 75 degrees would be being between 70 or 80, or if I'm more accurate, between 73 and 77. That's just a step too far. So based on that, you've then got to state your reason, you've got to state the answer and the reason. So, is the ladder safe to use? I'm going to say no. I'm going to say no because y, in terms of the angle we got, is not about 75. 3 marks.